All right, 21, integral of arctangent square root of x dx. So if you've done the integral of arctangent x before, you might remember that this is integration by parts, arctangent of x. So we might have to use integration by parts in this one as well. Okay, problem is there's a square root on the inside of the arctangent. Okay, so it's in the argument. So why don't we try a substitution first? Because otherwise, I'm not sure what to do. It's clearly not a typical trig integral that you learn the strategies of. It's not a trig sub. It'll make this way more complicated. And it's not a rational function for partial fraction decomposition. So let's try a substitution first. So I'm going to use t instead of u because I'm going to use u and v later. T, let's let it be square root of x. Okay, we can find dt right away, or if you don't know this trick, you can square both sides first so that it makes the differentiation a little easier. 2t dt is dx. So if you hadn't done this t squared first, you'll do dt is 1 over 2 square root of x dx, and then you would have to solve for dx. So 2 square root of x dt is dx. And what is square root of x? That's in our definition. That is t. So you see, you get the same thing. Yeah? Okay. So once we do the substitution, we get arctangent of t times 2t dt. Okay, I need the definition still, so I'll keep that, but I'm going to erase this. Now let's do integration by parts. So let's let u be arctangent of t. I don't want it to be our dv because we need to integrate arctangent then. I don't remember that off the top of my head. Du is 1 over 1 plus t squared dt. So dv is what's left. That's 2t dt. You can just put t dt as well, or you can just do 2t dt because v is t squared. So it cleans it up a little bit. Okay. So we do uv minus integral v du. That is t squared arctangent of t minus integral t squared over 1 plus t squared dt. Okay. I'm going to erase the integration by parts setup now. I need space. Okay. Now, how do we do this integral? It's a rational function, so we can do partial fraction decomposition, or we can do this trick. This is simple enough. Okay. So hopefully you would agree that 1 plus t squared minus 1 over 1 plus t squared is equal to this guy. I just added 1 and then subtracted 1. Ignore the dt first. Okay. So we can split this fraction up as 1 plus t squared over 1 plus t squared minus 1 over 1 plus t squared. And then this first term simplifies to just a 1. And this would be the result that you get if you do long division. Okay, so instead of writing the division sign and doing all that, you can just do this little hack over here. Okay, so t squared times arctangent t minus integral of, in parentheses, 1 minus 1 over 1 plus t squared dt. Okay, now let's integrate those two. So t squared arctangent of t minus t, this becomes a plus, arctangent of t plus c. And then we got back substitute our definition of t. T is square root of x. So this would be an x. This would be a square root of x. This would be a square root of x. This would be a square root of x. Let me double check my work with my previous answer. This looks right. Yep. Okay. So this is a typical two-technique integration problem where we first did the substitution and then we were in familiar territory of integration by parts.